Welcome to the Explainer. It feels like every single month we're waking up to terrifying headlines about extreme weather battering our coasts. So today we're diving straight into the actual science behind these massive storms, why they're getting so much stronger, and exactly how we can survive them. Let's just cut right to the chase with a question that is literally a matter of life and death for millions of people right now. Is the Brazilian coast actually ready for the next extreme event? As we've seen from recent data and those tragic headlines, our climate is shifting rapidly, and the window to prepare is closing fast. To really wrap our heads around the urgency here, just look at the sheer scale of the September disaster in Rio Grande do Sul. A staggering 300 millimeters of rain fell in just 5 days. Think about that for a second. That is almost double the rainfall they'd expect for the entire month, all crashing down in less than a week. And this wasn't just a heavy rainstorm, guys. It was the biggest natural disaster in the state's entire history. We're talking about winds ripping through at 100 kilometers per hour, nearly 5,000 homes just totally wiped out, and over 20,000 people displaced. Tragically, over 50 lives were lost in the Taquari River Valley alone. And all of this destruction was powered by a very specific atmospheric phenomenon. Okay, let's jump into Section 1, the cyclone machine and its thermal mechanics. Before we go any further, we need to separate myth from reality and define what we're actually dealing with. An extratropical cyclone is basically a massive low-pressure storm system that forms outside the tropics, usually between 30 and 60 degrees latitude. But the real key to its power is how it starts. It's driven by a massive collision between two totally different air masses, one fiercely cold and one intensely warm. Now, you're probably familiar with tropical cyclones, right? Like the hurricanes in the Caribbean that just feed off of warm ocean water. Well, our extratropical cyclones are a whole different beast. They're sparked by the aggressive, volatile clash of a cold front and a warm front. That sharp contrast in temperature, that is the exact ignition switch for the storm. Let's break down exactly how these storms suck energy out of the ocean. Step 1, you've got this cold, dry air rolling off the continent and over the warmer ocean waters. Step 2, as it travels, this dry air absorbs just massive amounts of heat and moisture through evaporation. Step 3, as that moisture rises up, it condenses into liquid way high in the atmosphere. This exact process happens perfectly off the coast of southern Brazil, right where the warm Brazil current smashes into the freezing cold Malvinas current. If that all sounds a bit abstract, Manuel Alonso Gon, a meteorologist from the National Institute for Space Research, has this brilliant analogy. He says it's exactly like wearing a wet shirt. You know how when you wear a wet shirt, the water evaporates and makes you shiver because it's stealing your body heat? Well, when all that moisture condenses high up in the sky, it releases all that stored heat right back into the atmosphere. Boom. That massive, sudden release of thermal energy is exactly what turbocharges the cyclone. Moving right along to Section 2. The El Niño factor and climate accelerators. So why is this getting so much worse? Well, in a world that's warmed by just 1.2 degrees Celsius, scientists from the World Weather Attribution Project estimate these extreme rainfall events can be up to 40% more intense. Think about that. A warmer climate might actually mean we get fewer cyclones overall, but the ones that do hit, they are packing way more moisture and significantly more destructive power. And then, if you throw a super El Niño into this already warmed planet, Brazil faces these fiercely polarized extremes. Down in the south and southeast, the atmosphere gets completely supercharged, bringing catastrophic rain, floods, and landslides. But at the exact same time, up in the Amazon, it acts in total reverse, literally choking the region with brutal droughts and dangerously low river levels. Which brings us to a critical part of the puzzle in Section 3, the lost natural shield. Here is the really scary part. While these storms are getting stronger, our natural defenses are getting weaker. All across the Brazilian coast, we're losing the natural shields that have historically absorbed the violent shock of storm surges and crashing waves. Researchers are pointing out severely depleted sand and sediment stocks. Our coastal dunes, which act as a vital physical barrier, are highly degraded. And perhaps worst of all, our mangroves, which are basically nature's ultimate shock absorbers, have been flattened and reduced. The root cause of this vulnerability? Intense urbanization. We've literally taken nature's sponges and paved over them with rigid concrete. By stripping away that natural absorption capacity, we've left our coastal cities incredibly exposed to sudden devastating flooding and aggressive erosion. And of course, rising sea levels are only multiplying that threat. All right, let's talk solutions in Section 4, Defenses and Urban Strategies. So, how do we actually fix this? The absolute top priority, heavily emphasized by climate scientists, is deploying nature-based solutions. That means we have got to proactively restore our mangroves and restingas. We need to replant riparian forests along our riverbanks and fiercely protect our vital wetlands. We have to bring these living ecosystems back to life so they can stabilize the soil and safely soak up floodwaters long before they reach our streets. But we can't just rely on nature. We also desperately need human engineering and much better continuous data. We have to upgrade our urban drainage systems to handle these sudden, massive downpours. We need sharper early warning systems and nonstop monitoring of sea levels, tides, and sediment. Oh, and for regions facing the opposite extreme, like the Amazon, expanding rainwater cisterns is an absolutely vital strategy for surviving severe droughts. I think researcher Marcus Paulette from Univali really hit the nail on the head here. He said, adapting cities and communities to new climate patterns is no longer a long-term discussion, but an immediate necessity. And he's absolutely right. It requires integrating science, city planning, and governance right now. We simply cannot afford to sit around and wait for the next cyclone to hit before we take action. I want to leave you with this final thought to wrap up our explainer today. Take a look at your own community. Is your city just watching climate change happen, or is it already actively preparing for it? Because the harsh, undeniable truth, driven by the mechanics and the data we've just walked through, is that the next storm is already brewing. Thank you so much for joining me, and stay curious.